Okay, so today what we want to talk about is factoring trinomials. So a trinomial, what we say is it's in the form of x squared plus bx plus c. So we already know that x plus 3 times the quantity x plus 4 is, let's see, x squared plus 4x plus 3x plus 12, or x squared plus 7x plus 12. We already know that, okay? But what we need to be able to understand is how can we determine, and you can keep this on there, I'm just doing this to create more space. How can we determine that m squared minus 22m plus 21 equals m minus 1 times the quantity m minus 21. What we want to figure out today is how do we determine the binomials and that equal the actual trinomial. So let's go, there's a couple of scenarios that we're going to deal with. If b and c, remember we have bx plus c, so if b and c are positive, if those have a positive value, what I'm going to do is I'm going to figure out the factors of c, or the factors of 20. And the factors of 20 are 1 times 20 would equal positive 20, and 2 times 10 would equal positive 20, and 4 times 5 would equal a positive 20. So now what I want to do is figure out the sum of those factors. 1 plus 20 is 21. 2 plus 10 is 12, and 4 plus 5 is 9. That's our key right there, is 4 and 5 equals b. So our factors of 20 equal our sum. Okay, so this is what we're going to say, is that to the binomials, which equal x squared plus 9x plus 20, is x plus 4 and x plus 5. And you can go ahead, do the FOIL method, do the matrix method, whichever you would prefer, to check it, and you will get this trinomial once you multiply it out. So let's try another one. If b is negative and c is positive. If b is negative and c is positive. All right. So what we want to do is figure out our factors of 12. Our factors of 12. Okay. Now, because I have a negative 8x, I'm going to go ahead and focus on a negative times a negative because my 12 is positive. Okay. So we need to know our rules for integers as well. Because I have a negative 8x, probably what's going to happen is I would have a negative times a negative to equal that positive, and then add the two negatives to equal that negative 8x. So this is what I would figure out. Let's see, my factors of 12 are negative 1, negative 12. Let's see, negative 2, negative 6, and negative 3, negative 4. So let's go ahead and sum of these numbers. The sum of these numbers, negative 1 and negative 12, is going to be negative 13. That doesn't work because I'm looking for negative 8. Negative 2, negative 6, there's my negative 8. And 3 and 4 wouldn't work because it's negative 7. So what I would do is use that to say x minus 2 times the quantity x minus 6. So we've just factored out our trinomial to figure out the binomials which equal it. Now let's go ahead and see if c is negative. All right, if c is negative, but here I have a positive b. So let's go ahead and think about this. All right. All right, I have a positive, and if it's a negative, then my factors are going to have to be a positive and a negative. So we want to definitely make sure that we're thinking about this when we're figuring it out. Let's see. we have a -1 and a +15. That's not going to work. And I have a -3 and a +5. And I could also say a +5 and a -3. Now, let's go ahead and see here. A -1 plus 15 is going to be 14. So I even know if I switch that around, that's not going to work because I'm looking for a +2. Let's see. Let me go ahead and switch this. I wrote the same thing. It should be -5 and a +3 there. Let's see. -3 plus 5 is +2. But a -5 plus 3 is a -2. So we want to make sure that we attach the correct value to the right constant in the binomial. It would have to be, it cannot be this, all right? It cannot be -5 and 3. Obviously, that's not going to work. So we would have to say x minus 3 and x plus 5. Okay, so finally, we have if B and C are negative. All right, so if B and C are negative, I have x squared minus 7x minus 18. Okay, so factors of -18. And I'm trying to come up with a -7x. So let's see here. -1 and +18. Not going to work. Let's see. -2. Let's see. Yeah, -2 and 9. Not. Let's see. -9 and 2. And then I have negative. Now, it kind of makes more sense that I would want to attach a negative value to the larger of the two numbers since I'm ending up with a -7x. So I'm just going to say -6 and 3. So what I'm using is my knowledge of factors of numbers. I'm also using my knowledge of rules of integers with these numbers. And once we do this more and more, you won't really have to create this table to figure it out. You'll be able to say, okay, these are the numbers that I need in order for it to work. Okay, so -1 and 18, not going to work. Even if it was -18 and 1, it's not going to work. The sum for that would be 17 or -17, right? If we switch the values around. -2 and 9 is a +7. -9 and 2, there's our -7. And -6 and 3 would be my -3. So this is the one that we want. So I would have x minus 9 and x plus 2. X minus 9 and x plus 2. Now, if we took this the next step, all right, if we took this the next step, what we would do is we would go ahead and say x minus 9 and x plus 2 equals 0. Like if I had this original problem right here and said equals 0. Okay, so then I could go ahead and say, let's see, it would be x minus 9 equals 0, x plus 2 equals 0, using that 0 property that we just had in our previous notes. And so I could say here that x equals 9, and here I would say x equals -2. So now what we want to do is we want to check this on our graphing calculator. So now what I'm going to do on my graphing calculator is I'm going to go ahead and put in this equation. I'm going to put in x squared minus 7x minus 18. All right. So now that I have that in, I want to go ahead and I want to graph it. go ahead and take a look at this graph. Now, look back at what we did in our notes. In our notes, I said my zeros, remember we talked about that, my zeros are x minus 9, x equals 9, and x equals negative 2. The zeros of this equation, remember that's our x-intercept. The zeros of this equation are negative 2, which is right there, and positive 9, which is right there. So you can always check your work by using the graphing calculator. So that's how we do that. So on the back of your notes, we have some problems. Here what I'd like you to do is to just use the notes that we did before and determine the binomials, which equal the trinomials, 12 through 15. On 20 through 25, basically what we're doing is what I just showed you here at the bottom of the page, all right? Having the equation equals 0. Okay, now that we have the expression, I should say, equaling 0. So we're turning it into an equation. For 22, or for 21 and 22, probably what you're going to need to do is, what you will need to do is you would have to rewrite it as y squared plus y minus 20 equals 0. So you're going to have to add or subtract the item to the other side of the equation in order for it to equal 0, and then determine the two zeros of the equation. Okay, thank you.